Okay, this is example number 3 of a series parallel circuit. We can identify that we follow the voltage out. We've got a resistor right here which is in series with everything else. This one's in parallel, these two are in series with each other, but they're in parallel with this one. So the first thing I want to do is write in the values that we know. So that's 12 volts. We know what our voltage total is. We don't know what our amperage is. That's what we're trying to figure out. So we're going to try and figure out our amperage, but we do know what all of our resistor values are. So resistor number 1 is 2 ohms. Resistor number 2 is 8 ohms. Resistor number 3 is 4 ohms. And resistor number 4 is 4 ohms. And so what I like to do on these is simplify the circuit. So I'm going to redraw the circuit. And I'm going to leave resistor number 1 there. And I'm going to combine resistors number 3 and 4. I'm going to illustrate that with a dotted line. So this is R1, R2, and this is R3 and R4. And I'm going to combine these two, which is going to be 8 ohms of resistance, because these two are in series with each other, so you just add them up. So 8 ohms of resistance. And this is also going to be 8 ohms of resistance. And this one's going to be 2 ohms of resistance. Okay, so now I can simplify this even more because I've got a parallel circuit right here. So I'm going to redraw that over here. And I'm going to leave resistor number 1 there. Here's resistors number 2, 3, 4. Draw my little line around it. And so this is actually going to represent R2, R3, and R4. And so what I'm going to do is I'm going to combine these two, and I can use the same value method. So I've got 2 resistors at 8 ohms divided by 2 equals 4 ohms of resistance. So this is 4 ohms. So there we go. We got 4 ohms of resistance here. We've got 2 ohms of resistance here. Okay, so now this is just a basic simple series circuit. So in a series circuit, these two are additive, so I can add 4 and 2 gives me 6 ohms of resistance. So I'm going to write that up here. I'm going to do it in orange. So this is 6 ohms of resistance. To figure out what my amperage total is, all I have to do is do some simple math. So I take 12 divided by 6 gives me 2 amps. Now if I want to figure out if I did this correctly, then all I need to do is fill in the rest of these blanks and see if it all adds up. So resistor number 1, that's in series with the entire circuit. So series circuits apply here, series circuit laws apply. So I can assume that I've got 2 amps going through that circuit because amperage is constant in a series circuit. So that's correct right there. So now I can figure out what my voltage drop is by multiplying these two together. 2 times 2 is 4 volts. So this resistor right here is going to have, whoops, let me write that correctly, 4 volts. So that's going to have 4 volts right there. So what we need to do is we need to figure out how much voltage is going to be dropped on this one and this one. Okay, so this one, these two resistors here are in series with each other, and this one's in parallel. So let me write my P there a little bit better so you can see it. So parallel. So these two are in series, that one's in parallel. So what I need to do is I need to figure out how much voltage is left. So if I subtract 4 from 12, that should leave 8. So on this one here, I should have 8 volts because that's going to be 8 volts going here. It's going to be going down this way, and it's going to be going this way. Now this 8 volts is going to be shared across these 2 resistors. So, but this one only has 1 resistor, so it's going to be 8 volts. So now what I can do is I can figure out what my amperage is here by doing some division. So 8 divided by 8 is 1 amp. Okay, so far so good. Now what I'm going to do is I've got to figure out what my voltage drop is here. Now there's a couple ways to do it. The easiest way to do it is because I have two resistors and they're both the same value, they're going to use the same amount of voltage. And they're going to split it because there's only two. So 8 divided by 2 is going to be 4 volts. So let's see if that works. And that way we don't have to do a whole bunch of math. So if we put 4 volts here and 4 volts here, then we can do our math and we can figure out our amperage there, because 4 divided by 4, 4 divided by 4, that's 1 amp. So now let's see if it all adds up. So right here with voltage, because these two are in series, these are added together, and so these two together is 8 volts, and 8 volts and 8 volts here, that's in parallel, so that's correct. And then this 8 volts and this 4 volts equals 12 volts, so that's correct. And so our amperage adds up too. These two are the same, and this one and these two should add up to 2 because these are in series. This is in parallel, so that should add up as well. So everything looks like it added up on this one. So that's the third example.